So now if we label the information we're given, we're told that we have a 95-meter tall radio tower. So that means the height of this tower is 95 meters. We're also told that the hill here is 50 meters tall. Now, the other piece of information is from this point, we know that the distance to the tower is 120 meters. So what we're asked to find is the angle of elevation to the top of the tower. So that is this angle measure right here. So from the line of sight, from the top of the hill to the top of the tower. So we have this horizontal, and the angle of elevation is up from the horizontal. So one piece of information that we're not given that we can figure out is from this point where our line of sight meets the tower to the top of the tower. We're not given that value, but we can calculate it because we know that the tower is 95 meters tall and we know the hill is 50 meters tall. So the distance from this point to the top of the tower must be 45 meters because that's the difference between 95 and 50. And so now what we're going to do is take away the information except for our triangle. So now we just want to find this angle measure. We're just concentrating on this right angle triangle. We have, for this triangle, if we're going to call this angle A, we have the opposite side and the adjacent side. So automatically you should know that we're going to be using tan. So tan of angle A is opposite over adjacent. We sub in the values we've got. So tan of A is equal to 45 over 120. And angle A then will be the inverse tan of 45 over 120. So we should use brackets again. So bracket 45 divided by 120. Close the bracket. Then inverse tan. And you get that the angle of elevation from the hilltop is approximately, if we run in the nearest degree, 21 degrees. So angle A is approximately equal to 21 degrees. Therefore, the angle of elevation from the hilltop to the top of the tower is approximately 21 degrees.